Welcome back to the channel. Today we have a very interesting topic. We are going to do something similar to TensorBoard for TensorFlow while training a neural network, but it is going to be just based on very simple code using the callback of TensorFlow and using matplotlib. I like this because it gives us an exposure to using callbacks and also to do dynamic plotting in matplotlib. All right, let's kick it off. So I have some code in here that I wrote already. And some data set that I downloaded. So you can find the links for that on the description section below. Um, but very simple code and the diabetes dataset. All right, so I have imported pandas and of course matplotlib for plotting, TensorFlow, and from TensorFlow, keras, we have the sequential model and dense layers. Cool. So running this and the diabetes data set is just a CSV file. We have like 8, 9 columns and around 800 or 700 data points. So reading it, CSV file, looking at the sample, all these columns, glucose, blood pressure and whatnot, and the outcome at the very end is our ninth column. And of course, it is our target variable. All right, so what we're going to do, we're going to split the data into X and Y into features and target variable. We're not going to do like some scaling and whatnot or anything like taking a fifth subset or whatever. It's very simple. It's not a focus for today. Just taking X and Y and looking at this very simple network here. We have building it, and of course we're putting the seed. We build it with 4 hidden layers with Raylo. We have 8 features going in, and of course a binary classification problem with sigmoid function, binary cross entropy. We have the learning rate 0.001 and accuracy as a metric. So very simple one, fitting it to X and Y that we just split, and a validation split of about 20% of our training set. We run it for 200 epoch because it's very simple data set, small one, so it's not gonna take very long time. As you can see, validation accuracy, loss and whatnot. This is very normal so far. Now, what you can do for this is either you just, and of course, if you have a very big data set, this is going to take hours or days. Maybe not in Jupyter Notebook really, but it's gonna take very long time, and you don't want to be staring at some numbers updating every 5, 10, or 15 minutes, right? What you can do now is you can just wait until the network has finished and look at all these metrics, has finished training, look at all these metrics by, and maybe you were lucky enough to actually save the data, and then just plot them using matplotlib or any other way, the way that we are doing it here, looking at the history, dictionary, and plotting accuracy, validation accuracy, and whatnot. But this is not really the most efficient way. There are many ways of doing it. And again, the one that we're trying today is not the best or the most sophisticated one, but I find it very, very interesting. So this is a Python file, Python script file, very clean. We're going to write the code together here to implement that callback that we are going to use in our Jupyter notebook. All right, so we're going to import a few um, libraries. So first one is Matplotlib, of course. Also, we will need TensorFlow. We need to import TensorFlow for the callback implementation. So import TensorFlow as TF. And then we need IPython. I'll show you why we need this later on, but we'll import the clear output and we'll see how to implement it later on. All right, so let's call the class plot learning curve, and it's going to be an implementation. We're going to override a TensorFlow keras class, so that has to be an implementation of the TensorFlow keras callbacks. The callback class. We're going to do very simple stuff. There are many methods that you can override. We're going to override two. The first one is on train begin. These are methods that belong to that class, so pass. The second one is on epoch end. Epoch And these are the only two ones that we are going to override from the callback class. On train begin, and the names really are very easy to comprehend and understand when they are called. So on train begin and on epoch end. So on train begin, we will just initialize a dictionary that will hold the metrics while training, so like loss, validation loss, and whatnot. So self.metrics is a dictionary that from metrics, and yeah, so these two functions or methods will take logs. We'll take the logs, which is a dictionary from TensorFlow keras that holds all the metrics pertaining to the network. So we'll go through the logs dictionary, and then we'll take all these metrics, we put them into our dictionary that we can update on epoch end. So self.metrics will go through every metric in the logs, and then we'll store it in our dictionary. This is all what we are going to do at the very beginning. And of course, because we've just started, it's going to be empty, and we are making it a list, an empty list, because it's going to be one element for each epoch. All right. So begin, yeah. So correct this begin and also epoch. So epoch as well. Epoch as well has, yeah, see that should not be out there. All right, so here we're going to do two things. First one is update the metrics dictionary every time we finish an epoch. And then after that, we use those values to plot. Very simple steps. So the first one is just, doing the normal thing on metrics dictionary, like updating every single dictionary anywhere else. We have access here as well on the logs, and of course the epoch. We're gonna use that in a second. So we'll go through the metrics at the end of this epoch on the dictionary logs, on the logs dictionary, sorry, and then we will take the value and we will append it to our existing metric in the dictionary. So that will be self.metrics, and then we'll take self.metrics, and then we'll just append the value, the very recent value from logs. Yeah, this is what we are going to do. Now, if it doesn't exist, then we'll just create a new one. So just to make sure we're not getting in, or we could have used as well like a default dictionary or something like that. But anyways, it's just too simple. Let's make it simple as well. So here that will be self.metrics metric, and that will be just a logs.get metric. Now, here at the end of each epoch, we are going to take the value and we're going to store it or append it to our already existing self metrics metric that might be loss or whatever. Now this is here where the juice actually happens. We will plot, we'll use matplotlib. So let's make it simple. Let's just do for loss and validation loss. You could do for accuracy and everything else or recall or whatever if you have them, but let's just do for loss and validation loss for today. For the sake of simplicity, I can share the code in GitHub for a more sophisticated code. All right, let's create a figure, plot.figure. Just to control the figure size, let's use maybe 12 and 3, 12 by 3. You can control that if you want it. And here, all right, yeah. So here, going back to Python display. So this one is used, the clear output, just to clear the previous plot, because you don't want to have as many plots as you have epochs. You want that plot just to keep updating while you're training. So now let's plot. Let's plot on the x-axis the epochs and maybe epoch plus 1. And then on the y-axis, you will put the values from the dictionary. That is the loss in this case. So we'll do two plots, one for loss, one for validation loss. And loss. And also we can just label it by the name, loss. Label is equal to loss. All right. Seems that something's wrong. Yeah, we have an additional one here. So yeah, remove this one. We can copy paste for validation loss. Same thing, just changing loss to validation loss. and everything should be okay to go. One more thing, let's just check as well. Yeah, let's check. Let's make sure we have validation loss before we plot it, because yeah, so if logs doesn't have validation loss, do not do it. If it has it, then plot it. Right, cool. And then what? Then maybe you can just plot the legend as well for the loss and validation loss, and we can also have a grid before we call the show. Um, show. I'm I'm also thinking, so plots metrics here. Yeah, this is why we put it there anyways, because I want to, yeah, let's print them. Let's print the loss and validation loss. So for metrics, in the list that we have on line 21, let's plot just using a print function. Just print the metric in an f string, so f metric, and then colon. Let's print self metrics. Let's print that metric, and also we have to make sure that this is the very last item, or sorry, last element on the list, right? So we just want to print the last one. Copy paste for validation loss, of course. Validation loss plus oh no, plus, yeah, plus. Cool. So what do we have here? Oh yeah. So let's round it as well. So round, let's do it 2, and then we can do the same here for the validation loss rounded. And yeah, there is a mistake as well here. So single quotes have to be replaced by double quotes. So double quotes instead of single quotes. And now this one should be okay. So this is really, oh yeah, one more thing, print the last one, just a line, the separator. So now we have our callback almost ready. I think it's ready. So we have two functions that we did override on train begin on epoch. And yeah, so saved, and yeah, and I think now we can go back and train. So we'll clear all outputs, start, we run from the beginning. But before we run this one, we need to override the callback argument here and add a list that is has to be an instance of our callback class that we just written. So callback list of plot learning. I think I did not. Let's go back there. Yeah. So let's import it. This is our class that we just built. Plot learning curve. Maybe I just can copy 180. No more than matplot. Oh yeah, matplot. Matplot. Saved. Go back. Run it again. Cool. Let's copy plot learning curve. Put it there on the list and run. Okay, run. Oh yeah, I did not run this. So run one by one, and then the network. Run it as well. Oops, callbacks. Yes, missing X. Run. And error again on line 26 on the class PLT flow. Oh, okay. So it's not epoch plus one, epoch plus two, and not plus one. So otherwise, it's not going to have the same number of items. Okay, cool. Save. Oh, yeah, it's mistake here as well. So this one is a silly mistake. So metric is the dictionary key. So correct this one, and then for that one, we'll take the last in the value. So metric, and then run. Oh, Cool. So as you can see here, we have the yeah. So we have it running. Of course, not going to be that fast if you have a very slow training, which is supposed to be. It's just a toy data set, but you can see your loss, validation loss. You could also put accuracy, validation accuracy recall, or whatever you like, and you can take decision while you're training. But it's also cool that you don't need to worry and just look at it after you finish training. Yeah, this is really what we have for today's video. I hope you liked it. Stay tuned for the next one.